Demystifying Scikit-learn's kernel-ridge regression, a comprehensive guide. Kernel-ridge regression (KRR) is a powerful nonlinear regression technique in scikit-learn that leverages the power of kernel methods to handle complex relationships between features and target variables. Here's a detailed exploration of KRR. 1. The essence of kernel-ridge regression. KRR is essentially a kernelized version of ordinary ridge regression. While ridge regression operates directly on the input features, KRR works in a high-dimensional feature space implicitly defined by a kernel function. This allows KRR to model nonlinear relationships, capturing patterns that linear models might miss. 2. The key ingredients. Kernel function. The kernel function defines the similarity between data points in the transformed feature space. Popular choices include linear kernel simple dot product, suitable for linear relationships. Polynomial kernel models polynomial relationships between features. Radial basis function RBF kernel, a popular choice for nonlinear relationships. Using a Gaussian function to measure similarity based on distance. Sigmoid kernel introduces nonlinearity using a sigmoid function. Regularization parameter alpha controls the trade-off between fitting the training data and preventing overfitting. A higher alpha value promotes simpler models with less variance. Gamma. This parameter for kernels like RBF controls the influence of individual data points on the similarity measure. Smaller gamma values lead to wider influence, while larger values focus on closer points. 3. The mechanics of KRR. 1. Data transformation. The kernel function implicitly maps the original data points into a high-dimensional feature space. 2. Ridge regression in feature space. The ridge regression algorithm is then applied in this transformed feature space, where the penalty term alpha helps prevent overfitting. 3. Prediction given new data points. The kernel function is used to calculate their similarity to training points in the feature space, enabling predictions. 4. Key advantages of KRR. Non-linearity. KRR can capture complex, nonlinear relationships in the data, going beyond the limitations of linear models. Regularization. The regularization parameter effectively prevents overfitting, leading to better generalization to unseen data. Flexibility. The choice of kernel functions allows you to tailor the model to specific data characteristics and relationships. 5. Tuning KRR. Kernel selection. Experiment with different kernel functions to find the best fit for your data. Cross-validation can help guide this process. Regularization parameter alpha. Use cross-validation or grid search to find the optimal alpha value that balances bias and variance. Gamma. If applicable, tune gamma for kernels like RBF to adjust the influence of data points. 6. Practical implementation in scikit-learn. The kernel-ridge class in scikit-learn provides a convenient way to implement KRR. The YAML mentioned likely represents the parameters for this class. Here's a breakdown of the key values. YAML. Kernel function to use, e.g. linear, RBF, poly, alpha. Regularization parameter float, gamma. Kernel coefficient for RBF, polynomial, and sigmoid kernels float, degree of the polynomial kernel integer. Coa 0 independent term in polynomial and sigmoid kernels float. Fit intercept. Whether to calculate the intercept boolean. Normalize. Whether to normalize the data boolean. Solver to use for fitting string. Tolerance for the solver float. Maxiter. Maximum number of iterations for the solver integer. Random state. Random seed for the solver integer or none. 7. Important considerations. Computational complexity (KRR) can be computationally expensive, especially for large datasets and complex kernels. Interpretability: the nonlinear nature of KRR can make it difficult to interpret the models. Decision boundaries and feature importance. Data requirements: KRR works best with data that exhibits clear nonlinear relationships. Tuning: finding the optimal hyperparameters for KRR often involves extensive experimentation and cross-validation. In conclusion, kernel-ridge regression provides a powerful and versatile approach to nonlinear regression. By leveraging the power of kernel methods and regularization, KRR offers a promising alternative to traditional linear models when dealing with complex relationships in your data.